Next one on our list, all right? Find to the nearest minute all values of theta between 0 and 360 that satisfy the equation sine squared theta plus 2 sine of theta equals 5. All right, I see nearest minute, all right? Whenever I see that, odds are it is not going to be something nice, all right? So let's see what we can do with this. All right, whenever I have a quadratic, always get it so that I have it equal to 0. So I'm going to subtract 5 from both sides. If I subtract 5 from both sides, I get that. All right. I got to think of it in terms of x squared plus 2 minus, or 2x minus 5. I'm thinking, can I factor that? Things that multiply me 5, 1, and 5. You know, that doesn't give me 2, 2.5. I'm not going to deal with that. All right, quadratic equation. All right. So, A, term in front of sine. That's just going to be 1. B, term instead of, or that was sine squared. This is sine here. That's 2. And C equals negative 5. Notice we don't get the C over there. A lot of times people write it as 5, and that will massively change the problem. Okay, so let's see what happens. Using our quadratic formula, x equals, or in this case, not really x, we're dealing with sine. So let's put sine down. Sine of theta equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay. So, plugging in our knowns, negative 2 plus minus the square root of 2 squared minus 4 times 1 times negative 5 all over 2 times, well, a, which is 1. Right? Side note, if I get negative under there, we're going to get imaginary numbers, okay? If we have imaginary terms, we're never going to have a solution for that. That's just an FYI. It does happen. So whenever we get an imaginary or an I underneath or a negative radical, remember there are no solutions at that point. All right, let's continue onward. Plugging and chugging away. Negative 2 plus minus the square root of 2 squared is 4 plus 20 all over 2, which is negative 2 plus minus square root of 24 all over 2. All right, let's see if we can break it down. In other words, a hammer. Okay. 24 breaks down to 4 times 6. So the square root of 4, I do know, is 2. Negative 2 plus minus 2 square root of 6 all over 2. Oh, that's nice because it does break down to negative 1 plus minus the square root of 6 because all of them cancel each other out. Remember, it has to go into all the terms in the top to cancel, not just do that singletons, or else that's some bad stuff. All right, so there's sine of theta. All right, sine of theta equals negative 1 plus the square root of 6, and negative 1, not plus again, that's the same problem. Negative 1 minus the square root of 6. All right, let's see what those numbers are because I can't think of them. Negative 1 plus the square root of 6 is 1.4494 blah blah blah. It doesn't help me because if I arc sine this answer, you can see, what did I get? Error domain. Dun, dun, dun. Well, it just means it wasn't between negative 1 and 1. So guess what? No solutions to u. Alrighty. So that one's done. So second enter brings up the last term. I don't want that one. I want to change it to the one above it. So negative 1 minus that. I get negative 3. Wait a minute. Now, from the same logic, it's not between negative 1 and 1. That doesn't work either. Well, neither work. Guess what? Both of them fail. We have no solution to this. Okay? And remember, we can write this in two ways. We can write it as the null set or just empty brackets. Those are terrible brackets. You get the point. All right? So make sure you watch out for that. Nothing's going to work. This never, ever equals 5 or this doesn't equal 0. If you graph this one right here and you graph the line y equals 5, they never hit. Okay? So you can see we don't have any solutions to this, and that's the end of our problem.